Hello everyone. We're going to look a little more at graphing. So here I have a graph as if we've already set our scale. You can see here that each of the increments are by 0.2, so our x-axis scale is good. We can go over here and look that our y-scale happens to have the same scale. That's okay, and that's good. Every line is worth 0.2 points. The thing we're missing, though, is a title and labels for our axes. So the first thing we need to do is put labels on here. So I'm just going to make something up since this is practice. So let's say this is a velocity versus time graph. That means my x-axis should be time, which we use the variable t, and our units are seconds. And then the y-axis should be velocity, and our units are meters each second. And we will get more into that when we do motion. You don't really need to worry about that right now. Okay, the second problem we have, or third, I guess, really, because we needed a title and we needed to label our axes. So the third issue is this. We have our points plotted, but we do not have our best fit line. So to do a best fit line, you need a ruler or a straight edge. I know you can't see me using my ruler or my straight edge, but I do have one. And then you kind of have to just eyeball it so that it goes through kind of the middle of your points. Now, my line is a little bit low, but for the purposes of this, I'm going to let it go for right now. You really want your line to go through more of the data points. Let me see if I can make a quick adjustment here. Okay, that one's a little bit better. So the green one is the good one, okay? So drawing in a best fit line, again, it's kind of just eyeballing it. There's no perfect way to do it. The reason we do the best fit line is for more accurate results. Basically, it's taking an average of all these data points. When you're calculating the slope, you must use points on the line, okay? If we just could use data points, then we wouldn't even bother with drawing this graph. We would have just left the data points and used those. I should have said line. Okay, so again, when drawing graphs on here, drawing in your best fit line, try to go through as many of the data points as you can. Going through 0 is going to depend on what data you have. It may not always go through 0. And it should be a straight line if it looks like the data points have a linear relationship. We will be talking about more of that going forward. All right, next we need to look at how to interpret a graph. So here we already have a graph, and it is the cost in dollars versus the music or compact disc, okay? So here's some questions about our graph. Units for the slope. Well, when we calculate a slope, we use rise over run. Well, rise means the change in x, the change in y over the change in x, okay? So in other words, how much does the y increase as the x increases, okay? That is your rise over your run, okay? So we need to pick points on the line. So I would try to pick two that look like they're at a fairly good intersection. That one's pretty good. And then I'm going to go with that one because it's almost in the middle. I do not know why that just erased everything. But you get the idea. The good thing about this one is they have already given us the slope and the y-intercept. Oh, I see what I did. Somehow I switched the page. They already gave us the slope and the y-intercept here, so I don't have to calculate anything. So that makes our lives a little bit easier. When we're looking at the units, we're looking at what are we dividing by what else, or by what. So in this case, our slope would equal our y value, which is dollars, for each compact disc, okay? So we would be doing the cost in dollars for each compact disc. That's what the units on my graph give me for the slope. What does the slope of the graph tell you in this situation? Well, I really just said it when I gave you the units. It tells you how many dollars how many dollars each compact disc costs, okay? And I get that from my units. My units were dollars for each compact disc. The next thing you're going to have to do in physics is to write an equation that describes the graph. This is what we are going to be referring to as the mathematical model. So anytime you're asked to write a mathematical model, we're talking about the equation of the line. You have to think back to algebra and slope-intercept form. Okay, so the y is whatever is on your y-axis. The slope, let me do it a little bit. I'm still on the eraser. M is your slope. X is your x-axis. And your y, or your B, is your y-intercept. Okay? So it's called slope-intercept form. We're going to be using that to write all of our graph, or all of our mathematical models for all of our graphs. Okay? So to write an equation that describes this graph, I need to have my y value on the left, but I'm not going to use y because we have a word that tells us what the y-axis is equal to. So for y, I'm going to use cost because that's what's on my y-axis. And that's equal to my slope, which they have as 7 here. Okay. And I'm going to put units in here. So it's $7 per disc. And then I have music right here, so that 7 is going to be times my music. And then I have a y-intercept, which is 3.6. So again, to review, sorry about the bell, to review our mathematical model, if this was algebra, would say y equals mx, so this being your m, that being your x, plus your b, which is your y-intercept. All right, and then the last question asks us, provide an interpretation for what the y-intercept could mean in this situation. Well, the y-intercept is for when the compact discs are equal to 0. So wherever x is equal to 0, that's your y-intercept. So that's your B right there. Well, 0 compact disc still costs me $3.6. And we should have put that on there. So, what could that be? Well, if you've ever ordered anything through the mail, it could be a shipping charge. Okay, so there may be a flat rate shipping charge of $3.60. Okay, or a handling charge, or something to that effect. A membership fee that you pay for. Something like that. Okay, so what we did here was look at a graph, interpret the axes. We looked at the slope and the y-intercept, and we used them to make a mathematical model. And then we also interpreted the y-intercept for this situation. So we're going to be doing a lot of that in physics. If you have questions or you still need help on this or need more practice, please let me know so that I can get you the help that you need. All right, have a great day.